Okay. Now I've claimed that y equals x squared has a graph of y equals x squared has a parabolic shape. I've just claimed that, we haven't proven. It's so good. Okay. And it has 3 points because of the way we've constructed it: -2, 4, 0, 0, and 2, 4. Over here, we have the points 4, 4, 6, 0, and 8, 4. I'm going to calculate these points. If this is a graph of y equals x squared, then when x equals -2, what do you get when you square -2? If x equals 0, what do you get when you square 0? And if x equals 2, what do you get when you square 2? Now you should get 4, 0, 4, because then you would match the points at the corners of this fundamental square. And well, -2 squared equals 4. Now you shouldn't have to punch that into your calculator, but we'll worry about being sure about the calculations a little bit later. But we know that if you square -2, you get -2 times -2. -2 times, I'm going to write it down, -2 squared equals -2 times -2. It's 2 negatives, so it's got to give you a positive, and 2 times 2 is 4. Okay, so we'll get 4. A lot of people want to write -4, maybe because they punch it into the calculator wrong instead of actually calculating. You shouldn't be reaching for a calculator to multiply -2 by -2 or the square of -2. Okay. 0 squared. Well, that just means 0 times 0, and hopefully everybody understands that that's 0. And then 2 squared. Well, that's 2 times 2, and that's 4. So we get the point, -2, 4, verifying this point. The point 0, 0, verifying this point. And the point 2, 4, verifying this point. Okay, now what x values do we want to use to verify this? Well, the x values that we want to use the x values for the 3 points that we know have to be on this graph. Okay, we know -4, 4 has to be in this graph because if we move -2, 4, 6 units to the right, we get 4, 4. Okay, so when x equals 4, we want to know if y equals 4. Okay, and then here the x value is 6, the y value is 0, so we're going to use 6. And here we're going to use 8 because the x coordinate of this point is 8. Now, I want you to take a minute and plug each of these numbers into this formula. In other words, you're going to plug 4 in for x, and then you're going to do the calculation. And do the calculation by hand and do it with all the steps. Okay, hopefully you've done at least the first calculation. If you haven't done the other 2, you can pause in a minute and do them, but let's see how this is set up. You're going to get, if x is 4, then x minus 6 squared is 4 minus 6 squared. If you didn't write this out, you skipped a step. Now, I advise you not to skip a step, because if you skip steps, you're going to miss, you're going to risk missing something important. Okay, so you do 4 minus 6 squared. Well, 4 minus 6 squared, 4 minus 6 is -2. Now, you really should then write out these steps. I don't want to use up space on the board, so I'll just put a couple of dots here. And say that equals 4. So 4, 4. X is 4, y is 4. Well, right there, when x is 4, y is 4, those are the coordinates of this point, which again came to this point, moving it over 6 units. Okay, now what if x is 6? If you didn't write it out in detail, Write it out in detail. Okay. X is 6, what do you get? If X is 8, what do you get? Well, hopefully you've done that. And it's almost trivial, but 6 minus 6 squared is 0 squared, which is 0. 6 minus 6 being 0. Get 0 squared. Okay, X is 8. Get 8 minus 6 squared, which is 2 squared, which is 2 times 2, which is 4. And you get the 0.84, which matches the point on the graph. So this should go a long ways toward convincing you that this graph is the graph of y equals x minus 6 squared, or at least that the graph of y equals x minus 6 squared is a parabola with these 3 points. Provided this is a parabola with these 3 points, this has to be a parabola with these 3 points. Okay, now I want to verify the x minus 3 squared plus 6. I'm not going to do it by making a table. I have enough room to at least get a good start on it. Okay, so we have coordinates of some of the points on this graph. For example, this point came from x equals 5 and y equals 10. So this point should be 5, 10. Okay, so ask the question. Okay, for the function y equals x minus 3 squared plus 6, is y equal to 10 when x is equal to 5? If so, then this point should definitely be on the graph of this function. Can you pause for a minute and verify whether y equals 10 when x equals 5? Yeah, just replace x by 5 and see what you get here. See if you get 10. Okay, we've done that, but here's how it gets written out. Get y equals 5 minus 3 squared plus 6, because of course, we plug x equals 5, then you're going to replace x with 5. Well, 5 minus 3 is 2. And that gives us 4 plus 6, which is 10. So, yes, y equals 10 when x equals 5. Yeah. What's another point? Another of these 3 points. What are the coordinates of this point? Well, this was the x equals 3 line here. It might be a little hard to read. Hopefully, when you wrote it down, you did a better job than I did. But x equals 3, y equals 6. Can you verify that y equals 6 when x equals 3? Write that down. Pause. Maybe you've already written it down. Without pausing. Okay, well, that'd be great. Well, you get y equals 3 minus 3 squared plus 6, and you probably already see what's going to happen. 3 minus 3 is 0, 0 squared is 0. That's going to give you 6. So again, yes. guessing the answer to this question. And of course, if you plug in x equals 1, this point should be 110. Don't have a good place to label it. There's the point 110. If x is 1, we plug 1 in for x, you're going to get 1 minus 3 squared plus 6. And the arithmetic is again going to work out. And let me point out that I want you to do these simple calculations by hand, because you learn more by seeing how the calculation works out than by punching it into a calculator and accepting the answer. If it's a complicated calculation, that if we were using much bigger numbers, more complicated numbers, obviously you would use some kind of machinery to do it, but you would still want to write out as many of the steps as possible, so that you see how things develop and how they work out. It makes a bigger impression on you than punching it into a calculator and letting machinery do the thinking for you. All right. Now there's some found insights already, and just using some calculation with simple numbers and some simple, almost pre-algebra level mathematics, points on the plane and so forth, but in a little broader context than you would typically see in pre-algebra or even necessarily in an algebra class. Because of course, pre-calculus is something you learn after you've learned algebra. So ideally, you know a whole lot more algebra than we've even begun to touch on here. And if you don't remember it all, you'll remember it when you see it, and it'll come back to you. Okay. Now there's one more thing that we do with this fundamental square. Okay. And that's going to be what happens to this function if we double the height of this thing without changing the width. So we're going to talk about that in the next video.